Welcome to this new video on Docker series. So in this video, I'll be talking about some Docker commands, and in the previous video, we have discussed about what is a Docker image and anatomy of a Docker image. So I forgot to say one thing. This is the thing: a Docker image is composed of a series of read-only layers stacked on top of each other. Each layer represents a set of file system changes, and file system changes on which file system? The file system just below it. Like, what do I mean by that? The previous layer. File system changes with respect to the previous layer, and every Dockerfile instruction adds a new layer to the image. This we know. This we have discussed. So let's see what this part means. Like the layer, each layer represents a set of file system changes, and this only this line. Each layer represents a set of file system changes. So I will get a new one. So let me make it bigger. So we know if we have, this is a base image. Let's say I have a Dockerfile like this. I will make a Dockerfile first. This is my Dockerfile. So inside this file, I will have from Ubuntu something, from Ubuntu run something, run xxx, expose something, expose yyyy, copy something inside that. So let's say I have this Docker file. So this from Ubuntu will be the base image of mine. So this will be the first layer. Because we know each instruction in a Docker file corresponds to a layer in the image. So if this is from Ubuntu, so this layer will be, I have run like say sudo apt get update. So sudo apt get update. So what is this? So this is the second layer. So what is the second layer? The second layer, as we have discussed, the second layer is the file system change. Is the change file system. To better write this, we can say the second layer is the change file system with respect to the file system or the layer below it. So what this layer represents? This layer just represents the changes in the file system which we made just below this sudo apt get update layer. So this layer just contains the changes in the file system which we did from in the Ubuntu. Why? This Ubuntu is the file system, and we did some update in this Ubuntu. So this created a new file system. So just a minute. Yeah. So this is the layer. This layer represents, to write it REPRECN, represents the file system changes with respect to the layer just below it. So this is what I meant. Like this layer represents the file system changes with respect to the layer just below it. Like the changes to I have the Ubuntu layer below it. So the changes with respect to the Ubuntu layer. So this layer represents this one only. So next we have another layer. We will expose one. So this will be expose something. So this is the change. So this layer, just a minute, I will copy this one. So this layer represents the changes with respect to the layer just below it. So what is the layer below it? Sudo apt get update. So this layer, just a minute, this layer. So this layer, the layer I have here, let me take a red pen. Yeah. So this layer represents the file system changes with respect to this layer. And this layer represents the file system changes with respect to this Ubuntu layer. So this is what I wanted to discuss, like what is the layer. And this whole thing forms the image which you describe in the Docker file. So let's say you give your image name is like Surya image, let me. Surya. So this will be the whole image, and this will contain how many layers? 1, 2, 3, 4. 4 layers. And in this 4 layers, the base will be the Ubuntu, and above it will be the file system changes based on the Ubuntu file system. So this is what I wanted to discuss. And let's get to the main part, which is like the Docker commands. So let's get started. I will minimize this one. Yeah. So let's see, I have any images here or not. Docker images. So this is the same EC2 instance which I was using. So I have no images, so I will just pull an image. Docker pull Jenkins/Jenkins. Yes. So see, it is getting pulled. So as we also have discussed, we can inspect image using its ID. So let's do Docker images. I have this image, so I will just copy this image ID. And what I will do, Docker inspect this image ID. So as you can see, we have discussed these are the layers of this Jenkins image, which we have just discussed before. These layers, the same as this one. And we have a overlay directory, you can see. So what is overlay, we'll discuss in another video, but to give an idea is like in overlay, we have three three directories. And the overlay file system is a file system in which you can mount more than one file system, and you can view that file system as a whole one file system. So let's just give you a generic idea what it is. So let's say you have 2 to 3 file systems, so you want to merge those things. So let's say this is your lower directory. This will be only read only. This will be your upper directory, and this will be your merge directory. So what it does is, like, let's say you have this one, this is the lower directory, which is like read only. You cannot make changes to this directory. Only you can change to the upper directory. And when you view from outside, you get this two merged, and you feel like this whole is a one file system. But this is not. You can have multiple lower directories. If you view from the top, you will view it like this whole thing is a like combined view you'll get. So it will feel like you are interacting with a single file system, but these file systems are merged to this layer, and you can see the merged view. So this is what merged file this overlay file system does. And because of the overlay file system, you can reuse the images. Like when you create a container out of an image, let's say you can create multiple containers of a single image. But how? Because this forms a read-only layer on top of these images. So this image you can share with every other container, but every other container will have another layer. This layer will be different for every container, but this base layer will be same. So this will be merged, and you will view it like a single file system. So that is why this image can be shared between all the containers, because you are not writing into this, you are writing into this. And when you are running a container, this will be merged into a file system, so that it seems like you are interacting with this base. But this is not, and this is the reason you can share this image between multiple containers. And this is the great design, like it has been designed by the Docker guys. And this is the reason, like if you had, so let's say you cannot share this image, so you will have the same copy in every container. So that is the waste of storage, right? So this overlay file system helps us with that, with the image, helps us with the image, the base layer is also known as layer caching. So we will get into that in the later part of this series. So let's get back to the video. So these are the layers. This is the lower directory, this is the merge directory, this is the upper directory, and this is the work directory. So now let's see some commands. Let's get accustomed with some commands. So I will use the copy command here. So a copy command like cp helps us to copy files and folders between container and the local file system. What is the local file system? The host where you have installed the Docker. So let's say I will run it. Docker run in detach mode, and I will have the image ID. What is the image ID? I have to take the image ID from the copy. So I started the container, Docker ps. You can see this up. So let's say I want to, I'm in my home, right? Okay, so I'll create a file, fetch surya.txt. So I have surya.txt here. I want to copy this inside this. I want to copy this inside this container. So what I will do, I will use Docker cp, and the file name is surya.txt. This is the source from where I want to copy. I want to copy inside this container, so I have to use this container address, container ID. And inside container where? Let's say inside container, I want to copy this inside this container, inside this tmp folder. So you can see it has been copied. Let's see if it has been copied or not. So for executing any command inside the container, we can use exec with the container ID and ls tmp. What happened? I made a spelling mistake. This will be ls. You can see the file has been copied. Surya.txt. So let's say from Docker, I will remove this file now in my local. So rm surya.txt. After the flag, I guess rmf. Yes, you can see it has been removed from the host. So I will copy it from the container. So for copying it from the container, I just have to change the source and the destination. Temp / surya.txt, and I want to copy it here. So let's see it has been copied or not. Yeah, you can see it has been copied. So this is one of the commands which I wanted to show you. And there is another command which is diff, which tells you that all the changes to the file system of the container since it was created, like what you have added in the container, like I have copied and like I have deleted, I have copied, or I have moved any file inside the container. So diff will tell me that. So let's inspect, let's use diff. So I will use docker diff and the container ID. I have to copy it again, I guess. This is the container ID. So I'll paste it here. So you can see it gives me all the like things I have done. You can see I have copied this one. Everything is it gives us everything that has been done. So this is the command docker diff container ID. So the next one is port. So we know we can like you can run. Let me run another one container. Yeah, and we'll give a port mapping here. We want 8080 of this to go to 8080 of this container. You can see I have started another container docker psa. Yeah, I have two containers and I want to know the port mappings of this container. Let's say so I have a command which is known as port, and I have to provide this container ID with it. So it will give us the port mappings. You can see I have this port mappings which I have mentioned here. So another one is you can also rename a container. Let's say I start a container with this one, and with name I give Surya's container. I guess I did something wrong. What did I do? What was the command for name? I forgot. It was, I guess, name q. Speed was the name was like. Acha, okay. I have to change this here. Yeah, so yeah, I have this port mapping, so I have to do it. So why this error came? Because I have my host machine port already mapped to container, so I have to do iterate on. The container is already used by container. Let's change the name. Just see, yeah, my container is created. PS, sorry, docker ps, docker ps a. I guess it's slow, it's taking some time. Let's wait. I guess there's some issues with the connection, so I re-establish the connection and come back. So I stopped, like my connection got like it was disconnected from this instance, so I've connected it. So I've started this container again, which the name was Surya containers, right? So let's now rename it, like, okay, so docker rename. I will have to give the container ID. Sorry, it took the. So the container ID is this one, and I have to provide the new name. So new name. So now let's run docker psa. You see the name of the container is changed from Surya containers to new name. So this is how you can rename a container. And the one is you can monitor the containers. So for monitoring the containers, there is another method which is like stats. So docker stats, and you have to give the container ID. Container ID is this one. Created. Which one is up? Yeah, this one is up. So I will paste it. So here you can see the stats of the container, how much memory it is using, network, and how many PIDs it have, and name of the container, etc. You can get out of this also. So I've got out of this. So here you can use stats command. Also you can use logs, docker logs. It will give the logs of the PID one of the container. Again, it's got new name. I don't know how. Docker PSA. This is up. So I'll copy this docker logs, and you have to paste it. So this gives the logs of the PID one of the container you are running. So I am running Jenkins, so it will be, I guess, /bin/tini. So these are the logs of the PID one. You can also use the top command. So generally in the top command gives us what are running things in my host machine. The same command is there in the docker. So docker, I have to give the container ID. Container ID was this one. Copy this one, and I have to paste it here. And this gives the top. You can see. htop is also there in my machine. Yes, this one is the graphical, like the same thing, but it is htop. I don't think htop is available with Docker. Yeah, it's not available. I guess I did some mistake again. Yeah, it's not available. And also there are Docker events. So I will use another terminal. So what I will do, I will just do Docker events. This is just to monitor the Docker daemon. So now let's say I have these two terminals side by side. Let's say I have these two terminals side by side, and now I am a container here. Docker run Jenkins in detached mode. You can see this monitoring. I have started the container here. I guess it not get started because I used the flag wrongly. It will be here. So you can see it is monitoring the Docker daemon. The Docker daemon started this container, so it's printed the logs here. So let's pull an image. Pull Ubuntu. So I pulled Ubuntu. Docker run Ubuntu. If I didn't download the image like using pull and ran direct to Docker, so it also would have run the Ubuntu, but it will first check I have Ubuntu here in my local or not. If I don't have, it will pull from the registry, which is hub.docker. See, you can monitor the Docker daemon using this Docker events Docker events command. So this is what I want to discuss in this video. So thanks for watching the video, and like this video if you like this one. Thanks a lot. Signing off.